Welcome back. We are talking about wastewater treatment, under which we are discussing about different treatment operations under secondary treatment. In this video, we will be discussing about the most important, one of the most important parameters in the activated sludge process, secondary treatment, is MLSS, MLVSS, and sludge volume index. So now if you look at this particular picture, what you are noticing is the primary effluent is now entering into aeration tank. This is aeration tank. In the activated sludge process, what will happen is we are recycling some amount of the sludge back into the aeration tank. So the return sludge, a part of the return sludge is now joined here. And these two are combined to form a combination of normal solids entering the aeration tank plus higher concentration of the sludge solids, which we are calling as mixed liquor suspended solids, MLSS. And there is some volatile portion also in this, because this MLSS consists of inorganic as well as organic solids. So organic solids, they are volatile. So that's why they're called as MLVSS, which are usually around 80% of the MLSS. So now how you are going to determine the MLSS? Once we take a sample from this liquid, then we are going through gravimetric method for determination of MLSS as well as MLVSS. The procedure is similar to how we determine the total solids and total volatile solids from the wastewater sample. It's a gravimetric method. First, we take the filter paper and then you weight it and then filter the solids through the filter paper, and weight of solids to the filter paper is a W2 after woven drying at 105, where the entire water is evaporated and leaving the dry solids. So the W2 minus W1 will give you the weight of dry solids in the sample of volume V ml. So if you convert it to liters to multiply with 1000, so W2 minus W1 into 1000 divided by V. Similarly, whatever the residue obtained here in the first part, that is heated in the muffled furnace at 550 centigrade, so that all the volatile solids are evaporated. And we are going to take the difference of W2 and W3 and for volume of V. So this is going to give you the amount of MLVSS. So if you look at the data regarding the concentration of MLSS and milligrams per liter, the complete mix process is around 3000 to 6000 milligrams per liter. Plug flow process is around 1500 to 3000 milligrams per liter. Extend aeration at 3000 to 8000 milligrams per liter. So this MLSS concentration will play an integral part in designing the parameters of activated sludge process. And at cases, we also go with the MLSS, MLVSS concentration, which we take as approximately 80% of MLSS concentration. Now, other parameter which is of most significance in the activated sludge process is the sludge volume index. It is defined as the volume occupied by 1 gram of MLSS in 1 liter volume jar after 30 minutes of settling time. And this is where we talk about the MLSS more. The settling of MLS is nothing but the recycled sludge coming from secondary sedimentation tank. So we want to know the sludge volume, the sludge settling after the second sedimentation. For that, we go for this test. So how much volume is occupied by 1 gram of MLSS in 1 liter volume jar after 30 minutes of settling time? We take a 1 liter volume jar and we put the MLSS into this recycled sludge, and we will note down what is the volume of settling after 30 minutes. So now you see in this very clearly, start of the test, all the water and solids are thoroughly mixed here. So there is no segregation and separation. After 30 minutes, the solids are settled down, leaving water to the top. What is the volume of this settled sludge we take, and what is the concentration of MLSs we take? Based on this information, we'll calculate what is the sludge volume index. So it is defined as settled sludge volume in ml per liter divided by MLS's concentration milligram per liter. So if I take this as settled volume in ml per 1 liter or 1000 ml divided by milligrams per liter of MLS's concentration. So what you are going to get will be ml per mg. So that's why we have to convert into milliliters per gram. So Vx by x is equal to 1000 Vx by x. Here we normally denote x as the MLS's concentration. So usually we write SVI in liters per milligram rather than ml per gram. So applying the appropriate conversion factors. So SVI in liters per milligram is equal to SVI in milliliters per gram into 10 to the power of minus 6. So desirable value of sludge volume index for good settling is around 80 to 20. Typical values are 100 ml per gram. Let us take a small example to understand the calculation part. In a SVI test, 3000 milligram per liter MLSS settles to 300 ml in a 1 liter jar. Calculate its SVI. So Vx is nothing but the settled volume given as 300 ml. And the initial concentration of MLSS here, this is 3000 milligrams per liter. So what we are having is Vx by x. Vx is nothing but 300, Vx is equal to 3000. So now conversion factor, we have to put 1000 here. So ultimately what you are going to get is 100 ml per gram. So 80 to 120 of this value is a good settling, it indicates in the activated sludge process. In the numerical calculation, what we obtained is 100 ml per gram. Another parameter which we talk more in the activated sludge process is the recycling. But this is what we are talking here, the sludge volume index, whatever the sludge which is now coming down from the secondary sedimentation tank. For this SVI, we have calculated to understand the settling performance of the sludge. So now the second part is how much sludge is recycled back. The volume of sludge recycling is QR and the influent volume is Q. The recycle ratio we call it as QR by Q. How much volume of recycling is done to initial volume of Q. You write down QR by Q. And how to do this calculation part. Now let us take a system boundary here. Aeration tank and clarifier together as single unit of secondary system. So the solids entering are X naught and now going out is Q minus QW. QW is the wastage volume, Q is the initial discharge, Xe is the volume of this concentration of solids going out, and the solids which are leaving from the sludge cycle, this is from effluent cycle, this is from the sludge cycle. QW is wastage of the volume of the sludge and XR is the recycled sludge concentration. And this much sludge is now going back into the system where V is the volume and XR is the recycled sludge concentration and QR is the recycled sludge flow rate. So if you write the mass balance, whatever is the solids present is equal to going out this plus this. Effluent line plus sludge line should be balanced with whatever is there in the system aeration tank. So here Q plus QR, this is Q and QR is coming here and the concentration is XR now. This MLSS concentration after mixing with this sludge, this is nothing but your X here, recycled sludge, MLSS. Q plus QR into X is equal to QR XR going out and Q minus QW into XE. Q minus QW into XE. So now Q minus QW into XE, suppose we neglect this XE because this value is very, very small compared to the higher concentration of XR, XR. So now if you remove that, what we are having QX plus QRX is equal to QRXR. QX is equal to QR into XR minus X, and recycle ratio is nothing but QR by Q. If you rearrange the terms, it is nothing but X by XR minus X. We can also consider some of the other parameters like sludge, line recycles, the solids going out, but this contribution also becomes very small in the entire calculations. So simple calculations to find out the recycle is X by XR minus X. MLSS in the tank divided by difference of recycled sludge concentration minus MLSS concentration. Calculate the recycle ratio for X. MLSS is equal to 4000 milligram per liter and XR is equal to 10,000 milligram per liter. The recycle ratio is QR by Q is equal to X by XR minus X. So 4000 divided by difference of 10,000 and 4000. 4 by 6 is equal to 0.67. This is how we calculate the sludge volume index. And if you know the XR, we can also calculate the SVI from the relation. Now, if this snapshot shows the sludge which is there coming out from the sedimentation tank in a settled form. So now recycled ratio QR by Q is equal to R. So R is equal to X by XR minus X. So using a mass balance, we can write this equation also as X by 10 to the power of 6 by SVI minus X. Comparing these two, XR is equal to 10 to the power of 6 by SVI, SVI in milliliters per gram. So let us try to apply this formula. Recycle ratio you have to calculate for SVI of 10 ml per gram, MLS is of 3000 milligrams per liter. So XR is equal to 10 to the power of 6 by 100. So this is equal to 10,000 milligrams per liter. Now you substitute this equation now, X by XR minus X. So 3000 divided by 10,000 minus 3000, which is nothing but 3 by 7, 0.43. Sometimes sludge density index is another term used in the settling of the sludge from the activated sludge process, which can be defined as MLSS milligram per liter and VX ml per liter, and you take a conversion factors, you multiply with 100 here. So it's also written as 100 by SVI. So SVI we already calculated from general process. So 100 by SVI we can directly calculate. So desirable value of SDI, very good sludge, is around 1 to 2. That means if SVI is equal to 100, the SDI is equal to 1. If SVI is equal to 200 milligrams per liter, it is a 200 ml per gram. It is a 200 by 200. This is 100 by 200 is 0.5. So if SVI is equal to 50, then SDI is equal to 100 by 50, it is 2. So 50 to 100, the value of SVI, what it says is more desirable. So this is another way of understanding the same information. But usual desirable values are slightly plus or minus 100 ml per gram. You are able to maintain in the secondary sedimentation tank, the sludge settling properties will be good, and the performance of the activated sludge process will also be good. This is all about your importance of sludge volume index, recycle ratio, and the relation of these two with respect to MLSS or MLVSS. Thank you.